Let's check out some mole/stoichiometry questions from the 2015 Regents exams. Okay, if you take a look at the first one, we're asked to determine the mass of CO2. So what I'd like to do is put a little X above, and we have 9 grams of glucose. If you didn't know the formula for glucose, it's given above the equation. So I have 9 grams here. And what else? 9.6 grams of oxygen and 5.4 grams of water. Well, we have conservation of mass here. So my 9 plus 9.6 on the left has to be equal to X plus 5.4 on the right. And yes, you hear a little ding because that makes it quite easy to answer the question. The key, of course, is to use your calculator. So you're going to add the 9 plus the 9.6, and you're going to subtract 5.4, and you're going to find the answer as 13.2 grams. Don't not use the calculator. That's the key. Let's move to question 2. You're asked to balance the equation in the answer booklet. I put it here so that you can see how I balance, and just balance it and then check your answer against my answer or the answer key. All I usually do is just go from left to right, back and forth. So I start with iron. I have 1 iron on the left. I have 2 on the right. So to balance it out, I need a 2 on the left. I go to oxygen. I have 2 on the left, but I have 3 on the right. So I have to balance out the 2 and the 3, so I got to get both sides up to 6. So I need a 2 in front of my Fe2O3, and I need a 3 in front of my O2. But the key is to always go back and check your balancing, because as soon as you put the 2 in front of this iron oxide, you also have changed the number of irons, so it's 2 times 2 now, which is 4. So this needs to be 4. Double check it again. 4 irons on the left, 4 on the right, 6 oxygens on the left, 6 on the right. Now it's balanced. Let's move on to number 3. You're asked to determine a molecular formula for a compound that has an empirical formula of CH2O and a molar mass of 120 grams per mole. Molar mass is your gram formula mass, so you need these 2 pieces of information to go from an empirical formula, which is your lowest whole number ratio, to the molecular formula that is the actual ratio, in this case of carbon, hydrogen, and oxygen. So I have C, H2, and O. And again, I have a gram formula mass, also known as a molar mass of 120. Okay, so there's 3 steps here. Step 1, you need the gram formula mass for my empirical formula. Anytime I do a gram formula mass, I list carbon, hydrogen, oxygen. I list the elements, a number of times they're appearing in the formula, and I'm going to multiply those by the gram formula masses off of the periodic table. Right? So for carbon, here it is, it's 12. Hydrogen essentially is 1. Oxygen, I'm going to round it to 16. And for the most part, I don't see any reason why you can't just use whole numbers here. If it became an issue, you could always go back, but usually on the Regents exams, whole numbers are fine. So 12, 1, and 16. I got to multiply these out. 12, 2, and 16. And of course, then I have to add them up, and I get 30. So that's step 1. Step 2 is I'm going to take my gram formula mass of 120, and I'm going to divide it by 30. So 120 obviously divided by 30, I get the number 4. And now what do I have to do with that 4? I got to multiply it through my empirical formula. So it's going to be C4, H8, and O4. And there's my answer. That's the molecular formula. So again, 3 steps. Gram formula mass for the empirical formula. You're going to take that number and divide it into the actual molar mass. You're going to get a factor. In this example, it was 4, and then you multiply that number through by the numbers for the empirical formula. And then finally, in the last one here, we're going to determine a gram formula mass for heptanal, Gram formula mass, again, I like to do it in steps. If you're just plugging it into your calculator, sometimes you can make mistakes. We don't want to do that. Okay, so what I'm going to do here, let me erase this to give myself some room, and we'll put it right here. Now the only thing, of course, is that they gave us a structural formula, so I have to account for all of the carbons, hydrogens, and oxygens in heptanal. So I have carbon, I have hydrogen, I have oxygen. I got to count up my carbons. I have 7 carbons, and I got to go around and count up my hydrogens. And it's 14 hydrogens, and for oxygen there is 1. Same thing as before. I pull off the masses off of the table. They're already circled from the last problem. So I got 12, I got 1, and I got 16. Again, don't rely on your brain to do the math. Don't even just punch it in the calculator. Put it on paper. It's just a simple thing to do where you're not going to make a mistake, and practice this way. Especially with the math stuff, practice it on paper. So I got 84, 14, 16. I add them up, and the answer is 114. Check out more videos. This is part 1 of moles/stoichiometry. You can go ahead and head on to part 2.